Hello and welcome to the next lecture of object-oriented programming. On previous lecture, we have discussed the class diagrams and start to create our simple example and start to implement it in UML, C++, and C. Today we will continue this work, and before that I want to say a few words about an extra task. Firstly and mainly, I unfortunately haven't received any solution for my third extra task. And I know that this task is pretty complicated, but I want you to just try and send me at least some intermediate results, because some of them maybe also be checked, and I will give you some pluses even for some intermediate results. Again, I was asking you to create an application, a code for compilation, to compile it in Visual Studio, to allow it to print some Fibonacci array. But I add some constraint for you to try not to use letters at all. So basically this task is split into some more complicated but less with less volume solutions and tasks. So basically you need to understand how to replace some C constructions with ones from another's, and by those who can not use letters. I want to give you some hints. Firstly, I insist that you have to look exactly in syntax of C. So it's not C++, it's C language. In C++, this task is much more complicated, but I want you to look at exactly in C, because there are some stuff that will help you exactly in syntax. Secondly, I have already give you some examples about that you can just type some and name at least variables and functions with like _1 or like 1, 2, etc. So these names will be correct in C, and those names are not using letters. So it's good names, you can use them. Third hint that I want to give you is that it's better for you to work to understand to create some simple application in regular C without kinds of replacements of without some specific syntax like this, specific names like this, just regular code. Then look at constructions that you use and try to replace those constructions by those that doesn't use letters. You know at least that you can replace any name by stuff like this, and it will be your last replacements and last changes in the code that you will do. So start from simple application, simple app code, and then transform it multiple times to make some replacements of one syntax constructions by another's to finally remove letters. You will see that every time you will have less problems and less stuff that you have to replace, and this is the same process as any regular application development happens. So you start from very simple stuff, then make some changes, and this stuff become more and more complicated, but it still will still work as you expect. So I know that there are some complicated replacements and complicated problems, and for now I will not give you extra hints but maybe next time we'll give you some hints if I will not see any solution. Typically, every year I got on the solutions kind of like this, but this problem, something around 1 or 3 maximum solutions. But so far, none of you have sent me any solution. So I'm still waiting. I will give you 1 more week. And again, please send me some intermediate results. If I see that you have replaced something, if you have do some work on this task, and you see and you mention that, okay, I know how to replace this, how to replace that, but I have some problem with this kind of construction or that kind of, then at least you'll get some pluses, not all of them. And now I think that it's better to say that if I see some solution, the full solution will be for a full solution, I will give you 6 pluses because it's really complicated. If I see that you have done some work, it will be less, but anyway, you will be able to see some of them. It will be able to get some pluses for even some intermediate solution. So go ahead. I'm still waiting for a solution. So now let's return to our regular code. And now I want to continue our stuff and our work on object-oriented code. So my goal is to show you that to show you some basic stuff around C++ syntax and object-oriented approach. Again, object-oriented programming itself, it's programming, it's philosophy, so how you treat an application. In terms of this philosophy, you look at the program that you want to create, look at the solution that you try to build, and treat it like a set of objects with some communications. Let me open our previous work. Where is it? History and history. Okay, where we are. So where we have our schemas, object-oriented programming. Okay. Okay. So now it's about objects. Objects is something that has identity, state, and behavior, and your application will look like a set of objects that communicate between each other. All objects are split into classes. Class is a group of objects with the same structure and the same behavior. And classes also can be grouped into more base classes, and due to inheritance, it can be classified on more categories. Next, this approach can be used in different languages. Some languages support this kind of approach by syntax sugar, so by some special syntax constructions that helps to create application more simpler and look at the code easier. But still, you have to know that you can even use a basic x86 assembler to organize memory of application like an object style, and use some functions and pointers that will do all stuff like encapsulation, polymorphism, and inheritance. So it's still possible. It will take more time, but sometimes it's good. Next option is I want to mention that it's one of the best approaches right now, but it's not the only one, and I don't want you to look at like object-oriented programming is the best. I want to use only object-oriented programming. Low-level stuff is very complicated, not for me. I will never use it, and so on. unfortunately, it's not the best approach. It's not the good way of thinking. Good way of thinking is to look at the problem and combine different approaches, because sometimes it's better to use structured programming, basic algorithmic stuff. For example, if you want to create an algorithm that do some compression, that basically do some math, some stuff with bits, some bit streams, and so on. You can create very complicated object-oriented, using object-oriented approach. You can create a class bit, bit stream, a string, some compression algorithm, this, that, different implementations, replacements, and so on. And then your algorithm will look horribly in the code. But instead of this, you have to, you can just use a structured approach and implement a basic algorithm without any objects at all. Just you know that you have some void star array or char star array and a size and some malloc and free functions, and just do some bit changes, do some compression, allocate a new memory, copy some bits, look at them, and so on, just without any objects at all. And it will look simpler. And this is the key word, simplification. So, so the goal of dealing with complexity is doing simplification. So when you choose what approach to use, what language to use, what system or API to use, the goal always is, in the beginning, is simplification. So and a simplification mainly for you. So if something is simpler, so let's say it's simpler for you to use C, use it. If simpler for you to use Python, use it. But if it's simpler to use a structured approach, not object-oriented or not functional in this particular part of the program, use this approach. And most of modern languages like C++, Python, C#, it combines different approaches itself. So you can use the structured programming, object-oriented programming, functional programming in all of these languages. It's possible because it's not because every language developer wants to show that, wow, this is a very cool language, you can do like this, you can do like that, and so on. No, it's because smart guys who develop languages understand that sometimes it's easier and better to use one approach, sometimes another one, and so on. So it's just because it's for you, it's you who have to decide when use what. But to make a good decision in this to make a good decision on language, on technology, you have to know more technologies, more languages. In this case, you will have more abilities to make your solution the best. So again, the keyword is simplification. So make your work simpler. If something is simpler to do like this, do it. If something is like looks better but it's more complicated, it's not a good approach. Much better is to use simplification. Another example of this way of thinking is that talking about optimization, never start optimization of your application right away. Firstly, create your application simple way, create the code the most simple as you can, then add some complications. And only when you got all functionality works, but it will look slow and it will work slowly sometimes, then try to optimize only that parts that really slow down. So to do that, to select those parts, you always have some profilers who will show you which part is executed the most time, and so on. So never start doing complications right away. First, simple stuff, then add some complications by iteration. The same idea as this task start from simple application, then transform construction by construction, one by one, by small iterations, and every time test that it works. The same is here. So today I want to continue work with the C and C++ code that represent shapes. So here I need some implementation, and in terms of I need to create some drawing example. I think it's better to maybe I will find some simple code. Let me look just for rendering old. Maybe I got something prepared. Other no. Oh yeah, I got it. Awesome. I got an example that will help us to move on. Okay, so we have taken example. I have chosen an example of very classic stuff like shape and different implementation of shape like square, triangle, and circle is a very basic and classic example of object-oriented implementation where we can look at everything. So I have I have show you. I have just mentioned that sometimes and in most cases it's better to combine different approaches, and to implement this stuff we need to actually draw something. To draw something we need some window to create and to draw some stuff on this window. And I got some example code over here that will allow me to render some stuff on the screen, and this is what we will do. So we have started from creating stuff in C++, then we got the same stuff in C, and we have this stuff in UML. So unfortunately I have removed our old diagram, so let's create a new one and repeat the stuff that we had created. So again, this approach and stuff like classes, fields, attributes, all interfaces, communication between objects is the stuff that is basic for object-oriented approach, and it is implemented in basic schemas like class diagram. And I want to create a class diagram right away, the new one actually that repeats and copies the same structure that we have in code. So UML, it's a simplification or simple representation of the code, and right now we will create our full class diagram. Let's look in like Starbase one class diagram order process. Oh, it's a basic class diagram. Now I just want to create an empty one. So what classes we have? So we are working on two examples, example 2, example 3, and maybe we will do the same stuff in C#, but I think it's better to start from one language and then show how it looks in another one. So class, we got point, it has x and y. It's association, favorites. Actually, I'm first time using this stuff. Let's copy. Where can add? Okay. Oh, here we are. Add attribute. It will be x plus x int. Add attribute plus is int. We got int. Yeah, here we are. It's struct, so we can add. It's better to look and add. No. Struct. Okay, let it be class. It's okay. So another one is shape. Shape, and it has a private point location. It's a private. It's minus. It's location and it's point. It has a counter as a protected. It has a counter as a protected. Oh, sorry, protected. It's int. Now it has draw as a function. No, it has a function draw. Draw. Okay. So we can see. So no. Next. So let's save it. It will be open. One. Okay. Now we got square. Square. Next, add attribute. It has point triangle. Point. Oh, sorry, it's triangle. White triangle. White sculpture. Ah, sorry, length. It has length. Has length. Int. Length. Length int. And it has draw, scale, and perimeter. Okay. It has draw. It has scale. Scale takes a float f. Okay. Scale f float and perimeter. Measure, and it's int. Okay. Now we got a triangle and circle. So we got a triangle. Add attribute as let's call it points, or like rest points. It will be point 2. Let's call it response. It's not a good idea to call field the same name as a class name. So it's way of naming, so it's possible to do that, but it's not good. It will be abusing stuff, so it will look very strange sometimes in code, whether it is the name of the class or it is a field name. So it's better to not to intersect any names between class names and field names. Even if we use some special naming convention, we'll do it next time. So it's kind of draft code, and even if you use some naming convention that definitely show you that this is field and this is a class name, then it's still not good to use the same names in a class and a field. Firstly, if you have a class triangle, it's already part of triangle, so no need to repeat this word again in the field because it will be in the code always attached to the variable or object or instance that basically will already be triangle. So no matter to say that it's triangle points. Of course, so it's not good name like triangle points. Why? Because it's already triangle, and it's actually already points. But points can be distinguished from other stuff. So now I choose the name rest points. So rest points, it's okay. And maybe it's not perfect name, but it's much better than just triangle. So let's call it like this. Then I got draw operation. So again, right now this code looks very horrible. So far I just want to show you some vocabulary around this, like what is called like what and how to do basic code in C++. And then we will, so it's very draft, it's very raw code. And of course we will change it iteration by iteration and make it looks better. It will start working, it start drawing some stuff, and we will repeat the same in C. This is what I'm gonna do with you together. So need draw. This time we will save our work, and that's why we will no need to repeat this schema again, but I think it's good to repeat once again in just a little bit another editor to show you some variations that possibly can be, and I think it's good enough to repeat stuff. Again, I understand that the most stuff that I'm talking about you can look in a lot of different books, but my goal is to show you different ways and different looks and views of the same problem, how it can be implemented, some examples of how it's using draw. This is my goal. I just want to show more and more examples of stuff that you will be able to read in more detail in some books, but I want to show you some live stuff. Okay, it's pose, that is point, and I don't want to type every time like semicolon void. So right away, now we need to add some connections that, oh, it's not that. How it works. Oh, okay, like this. It's square, it's triangle, and no, and it's circle. So this is our structure that we have. We have a point as a basic structure. Again, I repeat that struct and class keyword basically means for a compiler absolutely the same. The only difference is that if I'm not specifying any humidifier like private protected, by default this stuff will be public in struct, or if I choose to make it class, to make a keyword class, yes, class, then these fields by default become private. So this is the only difference. For me, it's easier to use struct in this case particularly. So secondly, I have a class shape that has a method draw and 3 implementations, 3 subclasses. So this is called a base class. This is subclasses in case of this connection. This connection is called generalization or inheritance or classification. So you see that we have different terminology. It's a little bit different, but I want to show you some meanings. So let's add here where it is. Constructions, okay. Yeah. So terminology. So terminology, I want to show you here. Let's look like class. It's kind of the same. So field. It's also called attribute. It's the same. I'm trying to use the word field because attribute is stuff that in C# means absolutely a different, another option. But here you see it's called attribute. It's okay, but just I think it's better to use field instead of attribute because attribute means another option in some other languages like C#. So next, we have a method. It's also sometimes called operation. And sometimes it's called function. Mostly it's the same stuff. It's about so this class, it's a structure part of the class, and this is a behavior part of the class. And this behavior here it's called operation. But I think it's better. The best name is method. It's the most correct option. But sometimes operation function is also possible. Next, we have object. Object sometimes is called as an instance of class or just instance. So because it is instance. Okay. Next. Oh no, not like this. Okay. Next, what can be is generalization. It's also called classification, and sometimes it's called just inheritance. So the difference is that generalization, it's a connection between classes. Classification is also a connection between classes, and this is kind of synonyms. But inheritance is the stuff that generalization and classification implements. So generalization implements inheritance, and classification is also part of inheritance. So we'll add this vocabulary. So next, what we have here: minus, plus, and hash sign. So minus means private, hash means protected, and plus means public. All this stuff is view modifications. It's an option of constraint that means that this field is visible only for the shape class. not for triangle, not for square, not for circle, only for shape. And here we have a problem. Yes, we need to access by triangle to this location, but no hurry, we'll look at this better. Next, counter has a hash sign, means protected. It means that this field counter is visible by code belong to shape class and by code belong to any subclasses of this base class. So this subclass square will also be able, the code of its implementation like draw, scale, and parameter will be able to access the field counter. And public means it will be possible to access everywhere. So this method can be accessed by shape, by any external code, by the code of these functions, and so far, and any others. So we can see that this field is so this is modifiers of view. It's the same for operations and for fields. Now after colon we can specify the type. Again, it's not always a good idea to specify the types. It's better to specify it, but sometimes it's not something that very important. Again, any UML diagram is just illustration of part of the program. So just some view of program. So not always you need to add all internals of the class. Remember of encapsulation. So when you are trying to hide some implementation details, not because it's a secret, just because it's not important in your discussion. So now in our discussion it's important, the types of the classes, the type of the fields. That's why we display it over here. So next, I want to show another. Oh, here we are. So I want to show you another link, as a composition. And I want to show you that we have a composition of a point. It's not, by the way, the aggregation. We have discussed it previously, but it's composition because it's location. I want to make it at location because shape has a location field. We can specify it over here. Location, yeah. And its point, so shape has a composition linked to point because it has a location as a physical aggregation or composition, and this romp means that this class contains that one. It has a composition, not aggregation, because lifetime of shape is the same as the lifetime of point. Means that shape is not exist without point because it doesn't exist without location. It doesn't. If it doesn't have location, then it doesn't have a shape itself. So this is just an example. We can type it over here. We can also match it, illustrate it via the link, like this. So this is another option. Now we got schema that represents the same code that we have here. I see that we can see that it also have points in triangle, and we can even give this option away, so we can type okay, we can type 2 and uh, 2, which means that it's a rest point. 2 means it has 2 points as a match for rest point. So this is, I think, is better. This is a better schema that we will have. Okay, now let's get back to our code, and we see that now I think it's better to give some. So we have this implementation in C++. This is in UML, and this is in flat C. The same stuff. So let's start from C++ as a major and add some code that allow us to draw something on the screen. To do that, I think it's better to add some source code that I have already prepared, like this. And now let's start from doing very bad stuff. So again, it's a draft code. I want to add right now as much code over here and all required code from here to here. And it will be some amount of code. It will be not split in files like I have here. It will be only one file, and then we will start working with it and look at it more clearly, just starting to make it better and better every time. But we have to start from ground zero, which will be like this. So I need this code as a main that will so this is actually my very old implementation of some graphics that creates a very base window which allow us to draw any pixels on this window as a regular Windows window. So we need to work with code. So we have this stuff. We have no. We have this include. Okay. So we don't need this. Okay. Okay. We have a C++. Okay, we don't need this. We'll add stuff here. Oh. Okay. Now, what else? GR basic. No. I need a render base. So I need a render properties. Put it over here. Now, we see that we have removed some classes because we have defined but not declared them but not defined. So now render base, we need this. Okay. Okay. Blah 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 blah. Actually, it's direct text example. Very simple. Okay. Okay. Let's try to compile it. I think we'll got a problem with include. Can't open direct text. Okay. Let's search for it. Windows. So it's Windows SDK. No. Windows. Oh. We have Windows SDKs. Windows let's look at what we need. We need this file. I hope it will find it. It will be very pity if it's not. Da, 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 da. Maybe I will got another example. Desktop open helper. Okay. I got okay like this. Okay, that's another example. Have I found it? No. Awesome. Okay. I hope it will work. I have this additional include directory. Properties. Command line or like okay, command line. Include general include. It doesn't have this variable set. It's not good. Okay, let's look. Okay, I need the direct text. Where it is? Where I have a direct text server. Impossible that I don't have any direct text installed. Okay, let's look on DirectX SDK install. Install DirectX, remove blah blah blah, installation, quickly run. I need the DirectX run. Okay. Oh, it will take some time. Okay. I have a GPRS downloading. Okay. Hope it will work. Okay. Let's look then in the code that we have. So no, I don't have it. I need it as a DirectX SDK. Sorry. So let's then look at the code we have. It will start working after I have installed DirectX, and while it's downloading over here, we can look at the code that we have. So firstly, I want to mention that we will combine the regular structured programming with object-oriented. It's the way that most cases happens. So far, our application, what it have to do, it will create a form or a window with a direct text inside working, and we will allow to set pixels in this window just to draw something. And this is what we will draw. We'll draw square, triangle, and circle using the base class shape. And I think that it's better to make some examples. So I think that let's look at the code from beginning of what we have. We have included windows to allow us to create a window that will be used by DirectX to render stuff. For some reason, we need those macros, and firstly, even here, we can look at these macros, and the question is why I insist that this macro implementation is bad. Firstly, I think it's even, we got a copy here, we don't need it. but this implementation is bad. Pause this video and think why it is bad. Okay, the answer is that because in macro we can put any stuff, and even with some operators, like it may be called like 5 plus 7 and less 6 then, and this without any brackets will be replaced by here, and we've got some complications with the priority of different operators. In most cases it's complicated to solve, and we can't declaring and defining this macro over here. We don't know how it will be used, and we have to think that it may be used not good way like this. To make no mistake, and it may be some mistakes in a complicated code, is a good way to write macro when always all arguments like a and b over here will be implemented inside this as an implementation of this macro with round brackets. So just to be sure that priorities of operators we are using in this macro will be the same as we expect in this implementation of this macro. So it's much better. Now we have typedef that replaces ulong fx result. Fx means I think it's, I don't remember. This is a suffix that we have. We will rename it sometime, but it's like a fixed result as a error system code. We'll talk about error codes maybe next lecture, not right now, but error handling. So far we just need to know that this library implementation of the code over here will use these codes as error codes, and only one is good, is okay. All others are errors like this. So for some reason we are defining null. If it's not defined, okay, it's defined, fine. Secondly, we have a very interesting thing. I have a typedef of union like this. This is union, and this is typedef for it. So we can use a fixed color. Basically, this code has come from C, and it's better to use typedef, because other way you will have to type union every time and struct every time. But with typedef, you don't need to. In C++, it's okay to not to use these words. And here we have a union of fixed color. And you see that we can even do some methods not only in structs and classes, but in unions too. The differences between union and struct, I hope you know, is because all fields inside union will be combined in the same location and reference the same location in memory. So this value is 4 bytes. Unsigned long will take always the size of current architecture. Right now it's 686, so it's 4 bytes. If it will be x64, which is not supported by this code, it will be 64 bytes. If you so long will always take this one. It's actually nice to know that int always 4 bytes, short always 2 bytes, char always 1 byte, long 4 or 8 byte depending on architecture, 64, 86, long always 8 bytes. So you may be interesting to remembering this stuff, but it's more about system stuff, but still is just nearby. That's why I mentioned that. I hope you know this kind of syntax. It's colons means bits, so it means that it's a struct. So these 4 bytes is has 4 fields: B, G, R, A, which is blue. G stands for green. R stands for red, A stands for alpha, which is alpha channel. It's for blurring the color. So I got a static inline. We have already not just declaring the method with the implementation. So this will be a declaration. This will be an implementation or definition of this method. We can combine them in one definition and hope it is in line. That's why it's okay to have a declaration over here. We'll check how it works in different files, but so far so good. Static means that this is method actually in union, and this is arguments, and this is types of arguments, and static means that this method it's not connected to objects of this union or structure class. So again, it's interesting stuff. It's static means that this method it's not belong to objects, but it's belong to class, or in this case it's for union. It's a very interesting concept. It means that you can't access here any fields of the class like value. You have to have a separate variable over here for that. So I can't type just value equals something because it's static. It's not for object. It's for class. That's why it's called static. Static means this method is generic for all objects of this class, and in this case it's for union. What happens here? We are defining the object. We are defining the object like this. Object is called C. It's a type of this object. It's union. This is object. It's field of objects. This is how we're accessing them. It's very regular as a struct, and actually this code comes from C. But you see that it has a method inside union. It's impossible to do in C. But in C++, it's okay. It's agreeable. So it works. So I can't type as a regular method. I can use like value equals something, which will be accessing to the field of this instance of the class. But right now, it's not because it's static. We'll see examples of this call and the rest of the code. Next, we have a struct, which is anonymous. It doesn't have a name, but it's typed there for a fixed image. It's okay also. A fixed image will have a width, height, data size, and array of this data. This is the basic structure for working with these libraries. So we'll draw pixels in these kind of images, and then we will put it onto the screen on the window. So actually we have downloaded. Let's run it. Yes. Yes. Accept. Next. No. Next. They all know that it still will be. Okay. We got a num that represents some special stuff for printing. It doesn't matter right now. True and false for some reason. Okay. Font, which is okay. We don't need a font over here. It's stuff from rest of the code. We don't need it right now, but anyway, we have an implementation for. We don't have an implementation for this set of functions, which looks very procedural. But you see, it's like a method of a fixed image. I think it's better to add some implementation and then we'll make it object-oriented way. So far, it's implemented a procedural way. You see the same stuff as here. We see some suffixes, and here we see we have the same, but with the first argument as an image, and here it was as first argument a square as this. So it's an object-oriented code, but in C, not using C++ syntax. so far we don't add any implementation. We have it over here, but next time. So far, I just want to create just a window. Okay, what's next? We have render properties with function color, function pointers. It's regular C stuff. It's not C++. In case of C++, it will have to be virtual method. So far, it's just pointers. We'll change it. So it's object-oriented way of declaring methods, but it's for C. So you see, you have a lot of examples over here. So again, it's a function pointers, which will rendering engine will call when it's required. So if we look at main, you'll see that you have a render setup. We pass some functions over there and set up and then start. And this is typically a while one cycle that will do all rest stuff and call those functions when it is required. When we got a key down, when the this render engine detects it, it will call it. Okay. We have a window handle. It's an object of a Windows kernel, and it will be rendered by Windows rendering subsystem. We have a DirectX object, DirectX device, and the manager. So okay, we have finally installed it. I hope that we can build it right now. No such file. Nice. Okay, I hope we'll copy. See where it was installed actually. Does anybody remember? Next. Accept. No. Next. I want to see the path where it was installed. Windows DirectX. Where is the DirectX SDK? No. Maybe it's here. Microsoft SDK. Windows Kits. No. Come on, next. So, program file 686, Microsoft DirectX. Okay. My 26, Microsoft DirectX. Oh, here we are. We have an include, and I think this is enough. Oh, sorry. It's enough for pass here. There's a command line here. Apply. Okay. Build. Okay, now I got it compiled. Compilation is fine, but now I have a problem with linking. And because I need these three libraries. Copy. Properties. Again, it's very draft right now. I'm doing very not very nice code even in here and in setting up the project. We'll do some iterations by making it look better. Okay, so I need a general output additional library directory. Okay. Oh my, I have, my god. I occasionally start Internet Explorer. I don't need it. So I don't need library. I need here. It's 86. Over here. Over here. Apply. Let's build. Invoke main. Ah, yeah. Sorry, because we got to change it from console application to Windows application. It's in C++, code generation, language, subsystem, advanced subsystem, all subsystem, no, it's not here. General, it's output, advanced, linker, general, oh, here we are, subsystem, yeah, it's Windows, apply, okay, build, yeah, got it. Let's start and let's look at this. Hope it will work. Crash, awesome, because it has a empty callback. Okay, fine. Very nice. It has a bug already. We need to specify the callbacks. I got a sample implementation for Arkanoid. Okay, we are not doing Arkanoid game, but anyway, let it be. Bar screen. Let's type it. Okay. I need like this. Like this. Build. So again, I don't have a image clean, image draw bar. Okay, let's edit. I have a desktop. Okay, let's add all stuff. Code, JRBasic, jar external. Oh, okay, JRBasic. Okay. I have a lot of functions that draw a lot of stuff. Okay, draw bar. Let's try. Linkage specification. Okay. H. Nothing. Current document. Replace. Okay. Build. Brazenham. Okay, we need the Brazenham. We have this. Let's try this. Have a Brazenham implementation. Yeah, now we have a lot of code. But I think it's better to this part uses and defines struct dfpt. Yeah. Where is dfpt? It's not here. Yeah, yeah, I have added. Okay. I thought I have added this code. So we need to do some stuff to compile it, and finally got a dfpt. Yeah. Struct dfpt. Sorry. Yeah, I fixed the program. Struct underscore build uses unnamed struct. Unnamed struct. Why 128 Why it's not working? Ah, okay. No, I don't think. Core uses def_pt. Static struct. We can remove word static. Okay, let's do like this. But why? It is already defined. We got it. Over here, type def struct. Why it's not working? Ah, struct unnamed. Okay, I need a type def struct. No, not type def, but just like this. It's a global variable. Yeah, we don't like static with unnamed struct. Very nice names. I'm typing struct def_pt one font static. Okay. Core uses, this is also undefined function. Take 2 arguments. Nice. Okay, let's do like this. def_pt type def struct here. Why it's not defined? Why is that happens? Yeah, porting code from C++ to C sometimes is very, very painful. Okay, let's render properties. Okay, where we are. I hope that it will. We have defined. Looks like we have defined it a couple times. This is why I have a problem. fx color, fx image, def_pt, like this. Yeah, here we are some problem. Math, we can just add math. Yeah, it works. Let's start. Strange name. Why it's not drawing a bar? Let's look at this. Key down, mouse move. Let's look here. Okay, clean. It's actually not cleaning. Bar. Why? For some reason it's not printing. Very nice. Okay, I think that today we have to to make this. I have to make this. So let's look at main. I have forgot this. Full screen 0. Yeah, looks nice. Build. Yeah, it works. You see, I got a Arcanoidal. Wow, awesome. So we can draw something using DirectX so far. And next time, so we got a bunch of code. It's like 1,700 lines. Not much, but it looks very, very bad. It has different styles. We have some prefixes. It looks like we have put it multiple libraries and taken code from everywhere in one place, and it starts working. And we have even our own code that we will plan to draw like shape, triangle, sphere, and all this stuff, and actually we'll continue to work with it. We have a bunch of this is what I have discussed about algorithmic. So this is image draw image. No, bad example. It's clip line Bresenham. So you see, it's some algorithm of Bresenham drawing of the line. I think it's a line. Bresenham next. And actually, it's not good to do it in object-oriented way, because in object-oriented way, we'll have to we can apply this approach even for this algorithm and take as a Bresenham object point and add methods for them and add some algorithm split for one phase, second phase, different implementations, and some replacements of cases on handlers. And you see, this is a typical algorithmic problem where we have if else, if else, if else, if else. So it's multiple. It looks like a case structure that has different options for different cases. And in object-oriented philosophy, it's not good. It have to be replaced over small functions and just call it, and just you have to create an object with the correct method inside that will actually be called. Doesn't matter what if happens. So at the beginning of each for, I have to create an object that represents one of these cases, and it will be created based on this logic, on ifs, and then just execute one method that will be different depending on what case it was. And this is how polymorphic stuff works. But of course, it's not good for this kind of algorithm, because this is a readable algorithm that if you look at the book of how just Murphy wide line works, so how does this algorithm works, you can open the book, look at the algorithm, and see these for construction, ifs, and all cases that we got here. It's much simpler than doing some object-oriented implementation of it. That's why it's much better to keep an eye on simplification. And next lecture, we'll continue to do it. So this is much better to look into C, but we will start to replace this stuff in by C++ style. So now let's take this code and place it in C, but remove the class stuff. Class. We don't need class. We don't need point. We don't need square, triangle. I just want to keep, so you see, we can't call it. Okay, it's not a problem. We just remove it, put it here. And here we can just remove like this. Like this. B. Okay, this. Okay. Function calls not allowed in a constant expression. Nice. Okay. Let's look at here and take our implementations and put them somewhere in the end or here. And let's also add the same stuff. Try to do the same stuff in C. Oh, cancel. And general, yes. General, yes. General, yes, 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 yes. And linker, system, subsystem, Windows. Apply, okay, let's try to build it. Okay. It's a keyword, and it'll be very funny if I do like this. Nowhere. Okay. Come to definition. It's an interface. Nice. Release session line. Okay. ID3DX sprite. Okay. Let's try to look it. Call or like use in C. Method. Stern. Is it possible to use in C? Draw tile. Draw. It's just a draw method. Okay. It's looks like it's impossible to use in C++. In C. Okay. In this case, let's do very nice code. I just don't want to replace the code of drawing, so that's why it's better to take where it starts. It starts, okay, I need this, and I need sorry, I need this for drawing. Okay, and I need this to here, and let's try. Properties, render properties. Oh yeah, I forgot that. Okay, let's try again. Too few arguments to call. Too few arguments, illegal use of expression. Yeah, it's C style. Sorry. From RGB. Why I can't use this? Okay, bar color, I can specify it somewhere else. Actually, I don't know why. Ah, yeah, because it's a struct, I can't use it as an initializer. Okay, mouse move, mouse tab, okay. Maybe it works. You see C and C++ differences right now. Oh yeah, nice. Clip line. Fixed image clip line. Clip rectangle. Draw line. You see, it's links in C++. It's not C. So in C we don't have links. We have only pointers. Links is typically it's a pointer that can't be null, and it can be used syntaxically as not a pointer. It's just a sugar, syntax sugar. So it's not something that very important. So okay. Okay. It's nice to see the differences between languages because, as I have mentioned in the beginning of our lectures, that our one of the most important skill is to moving code from one to another. So clip line x1. Okay. So that's why you have to have a skill to easily translate from one to another, from one code to another code. From C to C++, from C++ to C, from Python to C, and so on. So that's why, oh, it's very useful skill. Let's try. Almost done. We don't have a render base. Okay. So again, render properties. What? Redefinition. Okay. I have to have a invoke main. Yeah. Okay. Windows subsystem. I have unresolved external when main unreferenced in function invoke when main. Okay. Sorry. Unresolved. C when main. Why this? I have it here. Oh, it's strange error. I was expecting another error. Oh, okay. When main. Okay, it's compile, fine. Compile, fine. Render 12. I don't need to render start. Oh, I need extern C. This stuff replaces the name in objects. It changes the no. It's 5 constant earlier. Okay. It changes names and allow us to contact and to link symbols from C++ to C. Invoke main doesn't have a win main. Why doesn't it have a win main? For what reason? To go like this. We expect it like this. Okay. 2. Now we have unresolved external symbols in render setup and reference in function results info. Okay, now we are having something. I still haven't understand what I have changed. Nice. Objects specified more than once, extras ignored. Unresolved external symbol referenced in function. Very nice. Yeah, I know. Source 2. The names of sources are different. It replaces one object by another. It's not good. That's why it's much better to rebuild like this. Yeah, much better. Much better. Okay, G full. Okay. You know what happened? Object source. So let me explain you. Do you remember this diagram? C to object. So C to object and C++ to object is 2. So after compilation of this, we have received source.obj. And without changing the name, we also have a source.obj. And it depends on what order these two files was compiled. And we got 2 different errors of linking because they replaces each other. You see, it's just a... And Visual Studio doesn't tell me that something wrong. Oh, nice. Oh, very, very nice. Already defined. Okay, let's rebuild. Oh, now it works. Set as startup. Where it is. Set as startup. Again, we got it. Awesome. So it's all for today. Next time we'll continue to work with this set of code to make it much better. Thank you. See you next time.